Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Picture this with me for a moment. It's 79 CE, and you're standing on the edge of ancient Rome's most terrifying punishment. Mount Vesuvius looms before you, its crater glowing orange against the Mediterranean sky. Roman soldiers grip the arms of condemned criminals, preparing to hurl them into what they believed was literally a doorway to the underworld. The heat hits your face like opening an oven, and the sulfur burns your nostrils. This wasn't just execution, this was cosmic disposal. Toss the unwanted into Earth's fire and let the gods deal with the rest. Now here's what's wild about this scene. Those Romans had absolutely no idea they were standing next to a geological time bomb that would, in just a few years, bury entire cities under volcanic ash. But they had stumbled onto something that would captivate human imagination for the next 2,000 years, the ultimate incinerator. Fast forward 17 centuries. Benjamin Franklin, the kite flying, electricity discovering Benjamin Franklin, is sitting in his study in 1783, writing in his journal about something extraordinary he'd witnessed. Iceland's Laki volcano had been erupting for months, and Franklin was absolutely fascinated. He wrote about watching nature's own furnace consume everything in its path, and here's the kicker. He actually suggested it as a solution for waste disposal. Picture one of America's founding fathers, the guy on the $100 bill, seriously considering volcanoes as garbage disposals. The man who helped write the Constitution was basically saying, hey, what if we just threw our problems into fire mountains? And you know what? I get it. There's something deeply appealing about the idea. Something almost magical about making problems literally disappear into the Earth's molten core. But here we are today, and boy, do we have problems that need disappearing. Every single year, and I want you to really think about this number, we produce 2.12 billion tons of garbage globally. 2.12 billion tons. To put that in perspective, that's enough trash to fill 5,753 Empire State Buildings. 5,753. Can you even imagine that mountain of waste? I was reading about this recently, and it just blew my mind. If you took all the garbage we produce in just 1 year and spread it out, you could cover the entire state of Connecticut 3 feet deep in trash. 3 feet deep. That's higher than most coffee tables. The entire state. So when you're drowning in numbers like that, the volcano solution starts looking pretty tempting again, doesn't it? I mean, Earth is practically offering us disposal sites on a silver platter. The Pacific Ring of Fire alone has 452 active volcanoes, 452 natural furnaces just sitting there, belching fire and molten rock. Then you've got places like Ethiopia's Erta Ale volcano, which has been bubbling away with a permanent lava lake for who knows how long. It's like Earth's own eternal flame, just waiting for us to use it. All told, our planet has over 1,500 active volcanoes. 1,500 potential garbage disposals, scattered across every continent except Australia. From Iceland's dramatic eruptions that can ground air traffic across Europe, to the gentle lava flows of Hawaii that tourists line up to photograph, to the explosive monsters in Indonesia that can literally change global weather patterns. But here's where things get really interesting. And this is what got me hooked on this whole story in the first place. The more I dug into this idea, this seemingly perfect solution of just chucking our trash into volcanoes, the more I realized we've been asking completely the wrong question. We've been asking, can we throw garbage into volcanoes? When we should have been asking, what happens when we do? Because here's the thing. And this is where the story gets absolutely wild. People have actually tried this. Not just thought about it, not just theorized about it, but actually loaded up trucks with garbage and driven them to volcanic craters. And the results? Well, let's just say Mother Nature had some very strong opinions about our disposal plans. The journey to understand why we can't simply toss our trash into volcanoes takes us through some of the most jaw-dropping science you've ever heard. We're talking about temperatures that would melt a car in 30 seconds, chemical reactions that create acid clouds visible from space, and atmospheric effects that could poison entire continents. But it also reveals something fascinating about human nature itself. Our eternal search for the perfect away place. Think about that phrase for a second. Throwing something away. Where exactly is away? On a planet that's essentially a closed system spinning through space, where does away actually exist? The Romans thought they knew. Toss it in the volcano, send it to the underworld, problem solved. Benjamin Franklin thought he knew. Let nature's own furnace handle it. Even today, with all our scientific knowledge, there's still part of us that looks at those glowing craters and thinks, that looks like the perfect garbage disposal. But what we've discovered along the way, through spectacular failures, classified disasters, and some truly explosive experiments, tells us something much more important than whether volcanoes make good incinerators. It tells us about the chemistry of our modern world, the complexity of Earth's systems, and ultimately, what our attraction to this impossible solution reveals about how we think about the planet we call home. I mean, when you really think about it, the volcano disposal idea is kind of like the ultimate fantasy of consequence-free living. Make your mess, throw it in the fire mountain, and pretend it never existed. But Earth doesn't work that way. Nothing just disappears. Everything goes somewhere. Everything transforms into something else. And sometimes those transformations are way more dangerous than the original problem. Over the next few hours together, we're going to dive deep into this absolutely fascinating rabbit hole. We'll explore the incredible engineering of volcanic systems, and trust me, they're way more complex than just holes in the ground with fire. We'll examine the mountain of garbage choking our planet, from plastic gyres in the ocean to electronic waste poisoning communities. Thousands of miles from where those devices were used, we'll uncover the disasters that happened when people actually tried volcano disposal, stories that were classified for decades because the results were so catastrophic. We'll dive into the chemistry of what really happens when modern materials meet molten rock. And spoiler alert, it's not what you'd expect. But here's what I'm most excited to share with you. This journey doesn't end with, here's why it won't work. It ends with understanding why chasing impossible solutions sometimes leads us to discover the real answers we need. The volcano disposal dream, as crazy as it sounds, actually taught us crucial things about atmospheric chemistry, waste processing, and ultimately about finding ways to live on this planet without destroying it, because that's what this is really about. It's not about volcanoes or garbage or even the wild chemistry that happens when the two meet. It's about us. It's about why we keep looking for magic bullets instead of facing the real work of creating a world where we don't need to throw problems into fire mountains to make them disappear. So buckle in. We're about to explore one of humanity's most persistent and impossible dreams and discover what it teaches us about the world we live in and the choices we make every single day. This is going to be quite a ride. The story starts, as many great disasters do, with someone who was absolutely convinced they had the perfect solution. So let's dive deeper into what we're actually talking about when we say throw garbage into a volcano. Because I'll be honest with you, until I really started researching this, I had the same mental image most people do. You know, a big hole in the ground with bubbling lava, like something out of a cartoon. Toss in your trash, watch it melt, done. But the reality of what volcanoes actually are, it's so much more complex and mind-blowing than anything Hollywood could dream up. Picture yourself standing on the rim of Hawaii's Kilauea volcano. Now, Kilauea is what scientists call a relatively gentle giant, as far as volcanoes go anyway. But even this gentle volcano is operating at temperatures that would melt a car in 30 seconds. We're talking about 2,200 degrees Fahrenheit down in that crater. That's hot enough to turn solid steel into liquid metal. That's hot enough to instantly vaporize water before it can even turn to steam. But here's what most people don't understand, and this is where things get really fascinating. Volcanoes aren't just holes in the ground with fire at the bottom. They're incredibly complex systems that connect deep chambers of molten rock, we call it magma when it's underground, to the surface through intricate networks of tubes, vents, and channels. Think of it like the world's most dangerous plumbing system. Deep beneath Kilauea, there's a magma chamber that's literally the size of a city. We're talking about an underground cavern filled with molten rock that could swallow Manhattan whole. And this chamber is connected to dozens of other chambers, forming an underground network that stretches for hundreds of miles in every direction. When Kilauea erupts, and it's been erupting pretty much continuously since 1983, it's not just spewing lava randomly, it's breathing. I love that word, breathing, because that's exactly what it's doing. The volcano inhales when magma pressure builds up in those deep chambers, and it exhales when that pressure finds a way to the surface. Sometimes it's a gentle exhale, like the steady lava flows you see in those gorgeous time-lapse videos. Sometimes it's more like a violent cough that can shoot lava fountains 800 feet into the air. The mechanics behind this are absolutely mind-blowing. Magma rises because it's less dense than solid rock around it. Think about oil floating on water. Same basic principle, except we're talking about molten rock that's been superheated to temperatures that would instantly kill any living thing. As this magma rises through the Earth's crust, it's under enormous pressure. We're talking about the weight of miles of solid rock pressing down on it. Now imagine trying to control a system like that. Imagine thinking you can just toss garbage into that complex, pressurized, unpredictable network and expect it to behave like your backyard fire pit. Indonesia gives us the perfect example of just how varied and unpredictable these systems can be. Indonesia is home to 127 active volcanoes, 127, and every single one of them has its own personality. You've got gentle giants that ooze lava like honey flowing down a hillside. You could literally outrun these lava flows on foot. They move so slowly. But then, you've got the explosive monsters that can go from calm to catastrophic in minutes. Let me tell you about Mount Tambora, because this is where the scale of volcanic power really hits home. In 1815, Tambora erupted with such violence that it ejected 12 cubic miles of material into the atmosphere. 12 cubic miles. That's like taking a chunk of mountain the size of Manhattan and launching it 50 miles into the sky. The explosion was heard 2,000 miles away. 2,000 miles. People in London heard this volcano explode. But here's the really wild part. That eruption changed weather patterns across the entire planet. 1816 became known as the year without a summer, because all that volcanic material in the atmosphere blocked sunlight worldwide. Crops failed across Europe and North America. People were literally starving because one volcano in Indonesia had a bad day. And we think we can control these systems? We think we can just drive up with a truck full of garbage and everything will work out fine. Different types of volcanoes work in completely different ways. And understanding these differences becomes crucial when you start imagining what happens when human garbage enters these systems. Shield volcanoes like Hawaii's Mauna Loa create those relatively calm lava flows I mentioned. The magma in these volcanoes is relatively fluid, kind of like honey when it's warm. It flows steadily and predictably, which is why tourists can get relatively close to watch the show. But stratovolcanoes, volcanoes like Mount St. Helens in Washington state, are a completely different beast. These monsters build pressure for decades, sometimes centuries, before exploding with unimaginable force. Mount St. Helens erupted in 1980 with the force of 24 megatons of TNT. 24 megatons. That's bigger than the largest nuclear bomb ever tested. It flattened forests for miles, turned day into night, and sent ash clouds around the world. The magma in stratovolcanoes is thick and sticky, like cold honey or molten glass. It doesn't flow gently. It builds up pressure until it explodes outward with devastating force. When Mount St. Helens blew, it literally removed 1,300 feet from the top of the mountain. It just erased 1,300 feet of solid rock mountain in a matter of minutes. Now imagine throwing your household garbage into one of these pressure cookers. Your plastic bottles, your old electronics, your kitchen scraps, all of it, getting sucked into a system that operates under pressures and temperatures beyond anything we can truly comprehend or control. But here's where the science gets even more fascinating. The temperature alone, those 2,200 degrees we talked about, that's just the beginning of the story. It's the chemistry, the pressure dynamics, and the absolutely unpredictable nature of volcanic systems that make them impossible to tame. See, when we think about incinerators, the ones humans build to burn garbage, we design them to operate at specific temperatures under controlled conditions. We can regulate the airflow, control the temperature, and most importantly, we can capture and treat all the gases that come out. We can turn the whole system on and off whenever we want. Volcanoes don't have on-off switches. They don't have pollution controls. They don't have engineers monitoring pressure gauges and adjusting flows. They're wild, ancient systems that have been operating according to geological forces for millions of years, and they have absolutely no interest in accommodating our garbage disposal needs. The pressure dynamics alone would turn any garbage disposal attempt into a complete nightmare. When material gets thrown into a volcanic system, it doesn't just sit there and melt politely. It interacts with the entire pressurized network. Depending on the type of material, it could cause pressure spikes that trigger unexpected eruptions. It could block vents and cause pressure to build up in dangerous ways. It could react chemically with the magma itself, creating entirely new types of toxic compounds. And here's something that really blew my mind when I learned about it. Volcanic systems are incredibly sensitive to even small changes. Scientists have documented cases where something as simple as rainfall can trigger eruptions in certain types of volcanoes. The added weight of water seeping into the system can be enough to upset the pressure balance and cause an explosion. If water can trigger a volcanic eruption, imagine what a truckload of garbage might do. But the most important thing to understand about volcanic systems is that they're connected to much larger geological processes. That magma chamber under Kilauea, it's fed by a hotspot deep in the Earth's mantle, hundreds of miles below the surface. The magma in Indonesian volcanoes comes from the collision of massive tectonic plates that has been going on for millions of years. These aren't isolated furnaces. They're windows into the fundamental forces that shape our planet. When ancient Romans threw condemned criminals into Vesuvius, they thought they were sending them to the underworld. In a way, they were right. They were sending them into a system connected to the deepest, most powerful forces on Earth, forces that built continents, created mountain ranges, and continue to reshape the surface of our planet every single day. So when we fantasize about using volcanoes as garbage disposals, we're not just talking about using a really hot furnace. We're talking about trying to co-opt geological systems that operate on scales of time, pressure, and energy that dwarf anything in human experience. We're talking about systems that can change global weather patterns, systems that can flatten mountains, systems that have shaped the very air we breathe. The real question isn't whether volcanoes are hot enough to destroy our garbage. The real question is whether we have any business messing with forces that powerful and unpredictable. And as we're about to discover, the few times humans have actually tried to answer that question experimentally, the results have been, well, let's just say they've been educational in ways nobody expected. But before we get to those spectacular failures, we need to really understand what we're trying to dispose of. Because modern garbage isn't just organic waste that would naturally decompose given enough time and heat. Modern garbage is a cocktail of synthetic materials and chemical compounds that nature never intended to process. And when you start mixing that cocktail with molten rock and volcanic gases, the chemistry gets very interesting and very dangerous very quickly. All right, so we've established that volcanoes are incredibly complex. Powerful systems that operate on geological timescales, with forces that can literally reshape continents. Now let's talk about what we're imagining feeding into these systems. Because when most people think about garbage, they're probably picturing their household trash, food scraps, old newspapers, maybe some packaging materials. But the reality of modern waste, it's so much more complex and horrifying than most of us realize. Every single day, and I want you to really sit with this number, humans produce 5.9 million tons of garbage. 5.9 million tons every day. That's like taking the entire weight of the Golden Gate Bridge and throwing it away daily. Just to give you some perspective on what that looks like in practice, Los Angeles alone generates enough trash every day to fill Dodger Stadium completely. Every day. One city, one baseball stadium completely filled with garbage. But here's where things get really mind-boggling. That 5.9 million tons per day adds up to over 2 billion tons per year globally. And this isn't just paper and food scraps we're talking about. This is a complex mixture of synthetic materials, electronic components, chemical compounds, and substances that simply didn't exist 100 years ago. I was reading about the Fresh Kills landfill in New York, and this is where the scale of our waste problem really hits home. Before it closed in 2001, Fresh Kills was the largest landfill in the world. How big? It stood taller than the Statue of Liberty. Taller than the Statue of Liberty. This mountain of human waste grew so massive it could literally be seen from space. Astronauts on the International Space Station could look down at Earth and point out our garbage pile. But Fresh Kills, that was just one landfill serving one metropolitan area. And compared to today's waste crisis, it looks almost quaint. Let me tell you about something that completely changed how I think about our waste problem. In 1997, a guy named Captain Charles Moore was sailing across the Pacific Ocean when he stumbled onto something that shouldn't exist. He found himself sailing through what looked like a plastic soup that stretched beyond the horizon in every direction. What he'd discovered became known as the Great Pacific Garbage Patch, and it spans an area twice the size of Texas, floating in the middle of the Pacific Ocean. Now, when most people hear garbage patch, they imagine some kind of solid island made of trash that you could walk on. But the reality is somehow even more disturbing. It's not a solid mass, it's a soup of plastic particles, some of them broken down so small they're invisible to the naked eye. These microscopic plastic bits are floating throughout the water column, getting eaten by fish, birds and marine mammals, working their way up the entire food chain. And that's just one garbage patch. There are 5 major garbage gyres in our oceans, each one accumulating plastic waste that gets trapped by circular ocean currents. The Pacific Patch gets the most attention because it's the largest, but there are similar formations in the Atlantic, Indian, and Southern Oceans. We've essentially turned our planet's circulatory system into a plastic processing facility, but the ocean plastic is just the tip of the iceberg. Let me paint you a picture of what's happening on land. In Ghana, there's a place called the Agbogbloshie dump, and 20 tons of electronic waste arrive there every single day. 20 tons daily of our discarded computers, phones, televisions, and appliances shipped from wealthy Western nations to one of the poorest countries in the world. And here's the part that really gets to me. Children, some as young as 8 years old, work in this toxic wasteland, burning circuit boards and computer cables to extract tiny amounts of copper wire. They're breathing in fumes from burning plastic insulation, working with their bare hands among heavy metals and toxic chemicals. Also, we can upgrade to the latest smartphone without thinking about where the old one goes. This is the reality of our away problem. We tell ourselves we're throwing things away, but away is just someone else's backyard, someone else's ocean, someone else's children breathing toxic fumes. Now, the chemistry of our modern garbage makes everything exponentially worse. Let's start with something simple, a plastic water bottle. Seems harmless enough, right? Just clear plastic should break down eventually. Except it takes 450 years for a single plastic bottle to fully decompose. 450 years. Think about that timeline. A water bottle you throw away today will still be recognizable as a water bottle when your great-great-great-great-great-great-great-great-great-great-great-grandchildren are alive. Styrofoam is even worse. Styrofoam never truly breaks down. Never. It just becomes smaller and smaller pieces, but it never actually disappears. Those tiny white styrofoam balls you see scattered around any takeout restaurant, they're going to be in the environment literally forever. We've created a permanent addition to Earth's geology in the form of microscopic plastic particles. Glass bottles need 1 million years to fully degrade. 1 million years. Human civilization as we know it has only existed for about 10,000 years. So we're talking about a timescale that's 100 times longer than recorded human history. But here's what really keeps me up at night thinking about this stuff. Modern garbage isn't like the organic waste our ancestors dealt with. For thousands of years, human waste was things like food scraps, wood, natural fibers, broken pottery, stuff that would eventually break down and return to the earth. Our garbage was basically just reorganized natural materials. Today's garbage is a cocktail of synthetic polymers, heavy metals, rare earth elements, flame retardants, plasticizers, and chemical compounds that nature never intended to process. We've created materials that are so foreign to natural systems that even bacteria, which can usually figure out how to break down almost anything, organic, just look at our synthetic materials and give up, and it's getting worse fast. By 2050, that's just 25 years from now, there will be more plastic in the ocean than fish by weight. More plastic than fish. Let that sink in for a moment. We're fundamentally altering the composition of Earth's water systems faster than most species can adapt. Electronic waste is growing even faster than plastic waste. We're producing 50 million tons of electronic waste every year, and that number is doubling every 5 years. Every 5 years. Your smartphone contains over 60 different elements from the periodic table, including rare earth metals that are strip-mined from environmentally sensitive areas using processes that contaminate groundwater for generations. But here's the really crazy part about electronic waste. Much of it contains materials that are actually valuable. There's more gold in a ton of discarded cell phones than in a ton of gold ore. There's more silver in a ton of computer circuit boards than in a ton of silver ore. We're literally throwing away treasure while simultaneously destroying environments to mine more of the same materials. The clothing industry has created its own waste nightmare. Fast fashion has turned clothing from durable goods that people owned for years into essentially disposable items. The average piece of clothing today is worn only 7 times before being discarded. 7 times. Americans throw away over 11 million tons of clothing every year, and most of it is made from synthetic fibers that won't biodegrade for decades. Then there's food waste, which you might think would be less problematic since it's organic. But food waste in landfills creates methane as it decomposes, and methane is a greenhouse gas that's 25 times more potent than carbon dioxide. We're throwing away about 40% of all food produced globally, while simultaneously creating one of the most potent greenhouse gases in the process. Medical waste presents its own unique challenges. Hospitals generate over 5.9 million tons of medical waste annually in the United States alone. This isn't just used bandages and empty medicine bottles. This is chemotherapy drugs, radioactive materials, biological samples, and surgical instruments contaminated with human blood and tissue. Much of this waste remains dangerous for years or even decades after disposal. Chemical waste from industrial processes creates another layer of complexity. Factories produce hundreds of millions of tons of chemical waste annually, including compounds that are carcinogenic, mutagenic, or toxic to nervous systems. Some of these chemicals remain dangerous for centuries. Others become more dangerous over time as they break down into more toxic compounds. Construction and demolition waste makes up about 40% of all solid waste globally. When we tear down old buildings, we're not just disposing of wood and concrete. We're dealing with asbestos insulation, lead paint, mercury switches, and dozens of other hazardous materials that were commonly used in construction for decades before we understood their dangers. And here's what makes all of this relevant to our volcano disposal fantasy. None of these materials behave predictably when exposed to extreme heat. Plastics don't just melt into harmless liquid. They break down into toxic gases. Electronics don't just burn away. They release heavy metals and rare earth elements that can contaminate air and water for vast distances. Chemical waste doesn't disappear in high temperatures. It often transforms into even more dangerous compounds. So when we imagine feeding our garbage to volcanoes, we're not talking about disposing of organic waste that would naturally decompose anyway. We're talking about introducing a complex mixture of synthetic materials, heavy metals, radioactive elements, and industrial chemicals into geological systems that operate on planetary scales. We're talking about taking the most toxic, persistent, and environmentally dangerous materials humans have ever created and mixing them with the most powerful and unpredictable natural forces on Earth. And as we're about to discover, the few times people have actually tried this experiment, the results have been educational in all the worst possible ways. Now we get to the part of the story that most people have never heard about, because while scientists and environmentalists have been theorizing about volcano disposal for decades, some people have actually tried it. And the results? Well, let's just say they provide some very compelling reasons why this idea stays in the realm of fantasy. Let me start with a story that was classified for 20 years. In 1984, Ethiopian health officials were facing a crisis that's unfortunately common in developing nations. Medical waste was piling up in the capital city of Addis Ababa, and they had no safe way to dispose of it. Someone, and I really wish I knew who because I have some questions for this person, someone suggested using Erta Ale Volcanoes' permanent lava lake as the solution. Now, if you've never heard of Erta Ale, it's this absolutely incredible geological feature in Ethiopia's Danakil Depression. It's one of the few volcanoes on Earth with a permanent lava lake, essentially a pond of molten rock that's been bubbling away for decades. From a distance, it probably looked like the perfect incinerator. Always hot, always ready, no need to light it up or maintain it. What happened next became a classified disaster that wasn't declassified until 20 years later, and even then, only because of persistent pressure from environmental groups. Trucks loaded with medical waste, we're talking syringes, contaminated. Bandages, surgical instruments, human tissue samples, and various pharmaceuticals started making the journey to Erta Ale's crater. The first load hit the lava lake and, well, let me describe what witnesses reported. The medical waste didn't just melt or burn like everyone expected. It instantly vaporized, creating this massive plume of toxic gas that rose straight up from the crater like a poison geyser. The plume was visible from 50 miles away, this towering column of grey-green gas climbing into the atmosphere. 17 workers at the dump site were hospitalized within hours. They were experiencing symptoms consistent with severe chemical poisoning, difficulty breathing, chemical burns on exposed skin, and what doctors described as acute respiratory distress. But here's the really terrifying part. The toxic plume didn't just dissipate. Wind patterns carried it across populated areas, and over the following weeks, hospitals in the region reported hundreds of cases of unexplained respiratory illness. But the Ethiopian officials figured maybe they just used too much waste at once, so they tried again with a smaller load. The second attempt triggered something even worse, a lava fountain that shot molten rock mixed with vaporized medical waste hundreds of feet into the air. The contaminated lava sprayed across their equipment, their vehicles, and the surrounding landscape, creating a toxic wasteland that remained dangerous for months. The Ethiopian government quietly abandoned the project and classified all documents related to it. But Ethiopia wasn't alone in this kind of thinking. Let me take you back to 1919, because apparently the volcano disposal idea has been attracting overconfident engineers for over a century. A French engineer named Henri Dufour was convinced he could use Mount Vesuvius, yes, the same volcano that buried Pompeii, as Naples' municipal incinerator. Keep in mind, this is just 40 years after Vesuvius had its last major eruption. But Dufour was apparently unbothered by such details. He arranged a demonstration using old furniture, wooden crates, and various household waste. The demonstration was attended by city officials, engineers, and reporters who were all curious to see this revolutionary waste disposal method in action. They loaded the waste onto platforms and lowered it into the volcanic crater using a system of ropes and pulleys. At first, everything seemed to work perfectly. The waste caught fire immediately and burned with impressive intensity. Dufour was probably feeling pretty smug about his innovation. But then the wind shifted. The burning waste created chlorine gas clouds. Remember, a lot of early plastics and treated wood contained chlorine compounds, and these clouds rolled across the mountainside like a toxic fog. Within hours, 2 entire villages near Vesuvius had to be evacuated. People were experiencing severe respiratory distress, chemical burns, and what we'd now recognize as chlorine gas poisoning. But even worse than the immediate health effects was what happened to the local agriculture. The chlorine gas settled on crops and contaminated the soil, making it unsafe for farming for several growing seasons. Dufour's revolutionary waste disposal method had essentially poisoned the landscape for miles around the volcano. The project was immediately abandoned, and Dufour quietly returned to France. But the damage was done, both to the environment and to public confidence in volcanic disposal schemes. World War II brought its own set of volcanic disposal experiments, and these were even more disturbing because they were intentional military research. Both the Americans and the Soviets independently started studying volcanoes for disposing of chemical weapons. The logic was similar to civilian waste disposal ideas. Find a way to make dangerous materials disappear permanently. The classified documents from Operation Inferno, and yes, that was the actual code name, weren't released until 1995, 50 years after the war ended. The American test took place at Alaska's Mount Redoubt, and they involved disposing of various chemical warfare agents in active volcanic vents. What the military discovered was that volcanoes don't just destroy chemical weapons, they can transform them into airborne toxins that spread much further than the original weapons ever could. One test involving mustard gas created what military reports described as uncontrollable toxic emissions, lasting weeks. The contaminated volcanic plumes carried chemical residues across hundreds of miles of Alaskan wilderness. But perhaps the most concerning finding from these military experiments was that volcanic disposal could actually make some chemical weapons more dangerous. Certain nerve agents, when exposed to volcanic heat and chemistry, broke down into compounds that were more toxic and longer lasting than the original weapons. The Soviet experiments, conducted at Kamchatka Peninsula volcanoes, produced similar results. Declassified KGB documents describe volcanic disposal tests that created persistent atmospheric contamination, affecting vast territories. Downwind of the test sites, both superpowers quietly abandoned volcanic disposal. Research and classified all related documents for decades, but the modern era has brought more subtle disasters that demonstrate how even small-scale volcanic disposal can have widespread consequences. In 2007, illegal dumping at Ecuador's Tungurahua volcano seemed initially successful. Local officials were apparently looking the other way, while various types of industrial waste were being disposed of in volcanic vents during periods of low activity. For months, everything appeared fine. The waste was incinerated at high temperatures. The toxic residues seemed to disappear into the volcanic system, and everyone involved probably felt quite clever about their disposal method. Then the rainy season arrived. It turned out that toxic compounds from the vaporized waste had been condensing on the volcanic slopes during cooler nighttime temperatures. When the heavy rains came, all of those concentrated toxins washed down the mountainside in a poisonous flood. The contaminated runoff killed livestock 50 miles downstream from the volcano. Fish populations in several rivers collapsed. Well, water became unsafe to drink across a broad region. The environmental cleanup took years and cost millions of dollars, far more than proper waste disposal would have cost in the first place. But the ecological damage was permanent. Some of the affected watersheds still haven't fully recovered. Hawaii has its own ongoing battle with illegal volcanic disposal, primarily involving tire dumping. This might seem less serious than medical waste or chemical weapons, but the results have been surprisingly far-reaching. When tires burn in volcanic environments, they don't just produce the toxic smoke you'd expect from any tire fire. The extreme heat and unique chemistry of volcanic systems breaks down tire rubber into microscopic particles that become airborne and travel on Pacific trade winds. Scientists have tracked tire-derived pollutants from Hawaiian volcanoes across thousands of miles of ocean. These particles have been found in ice cores from glaciers, in deep ocean sediments, and in wildlife tissues throughout the Pacific Basin. The Hawaii tire dumping has essentially created a distributed pollution source that spreads contamination across the entire Pacific Ocean, and this is from something as seemingly simple as illegally dumping old tires. But perhaps the most revealing case study comes from Italy, where small-scale illegal dumping in volcanic areas has been going on for decades. The Campi Flegrei volcanic complex near Naples has been used for illegal disposal of everything from industrial chemicals to electronic waste to medical materials. Italian environmental authorities have documented how volcanic disposal creates what they call pollution amplification. Instead of destroying waste, the volcanic environment breaks it down into smaller, more mobile particles that spread contamination much more widely than traditional disposal methods. They've found volcanic-derived toxins in groundwater supplies hundreds of miles from disposal sites. They've documented atmospheric transport of volcanic pollutants across international borders. Most disturbing, they've discovered that some compounds become more toxic after being processed through volcanic systems. The Italian research has shown that volcanic disposal doesn't make waste disappear. It transforms local waste problems into regional environmental disasters. What all of these disasters have in common is that they happen because people underestimated the complexity of volcanic systems and overestimated our ability to control or predict what happens when we introduce foreign materials into these environments. Every single case started with someone who was convinced they had figured out how to safely use volcanoes for waste disposal, and every single case ended with environmental contamination that spread far beyond anything the planners had imagined possible. But here's what really bothers me about these stories. They're not ancient history. The most recent cases happened within the last 20 years, and yet most people have never heard about any of these disasters because they were either classified by governments or covered up by the organizations responsible. The lack of public awareness about these failures means that people keep proposing volcanic disposal as if it's a new idea that just hasn't been tried yet. But it has been tried multiple times by different groups using different approaches, and every single attempt has demonstrated why it's such a catastrophically bad idea. The disasters also reveal something important about the fundamental chemistry of what happens when modern materials meet volcanic environments. These aren't simple cases of things burning up and disappearing. They're complex chemical reactions that create new toxic compounds, distribute pollutants across vast areas, and contaminate environmental systems in ways that persist for decades. Understanding exactly why these disasters happened, the chemistry behind the catastrophes, that's what we need to explore next. Because the real danger of volcanic disposal isn't just that it doesn't work. It's that it makes our waste problems exponentially worse. All right, now we get to the really fascinating part, the chemistry of what actually happens when our modern garbage meets molten rock. Because all those disasters I just told you about, they weren't just random accidents. They were the inevitable result of chemical reactions that most people never think about. And once you understand the science behind these reactions, the volcano disposal idea goes from crazy but maybe possible to absolutely terrifying. Let's start with something simple that's probably sitting in your recycling bin right now. Plastic bottles. Most people think plastic melts when it gets hot enough, turns into liquid, maybe burns away completely at really high temperatures. That's not what happens, not even close. When polyethylene, that's the plastic in most water bottles, hits about 1,000 degrees Fahrenheit, it doesn't just melt. It starts breaking apart at the molecular level, and this is where things get scary. Those long chains of carbon and hydrogen atoms that make up the plastic start splitting, and one of the main products is hydrogen chloride gas. Hydrogen chloride gas is essentially hydrochloric acid in vapor form. Picture this. You throw a few plastic bottles into a volcano. They hit that 1,000 degree mark, and suddenly you've got clouds of acid gas rising out of the crater. This isn't like the acid rain you might remember learning about in school. This is concentrated acid vapor that burns lungs on contact. Breathe in a good lungful of hydrogen chloride gas, and you'll experience what's called chemical pneumonia, where your lung tissue literally starts dissolving. But hydrogen chloride is just the beginning. PVC, polyvinyl chloride, the plastic in pipes, vinyl siding, and lots of packaging, releases something even worse when it's heated. We're talking about dioxins, which are among the most toxic chemicals known to science. Here's a number that will blow your mind. 1 gram of dioxin, about the weight of a paperclip, can contaminate 10 million gallons of water beyond safe drinking levels. 10 million gallons. That's enough water to supply a small town for months, poisoned by an amount of chemical you could balance on your fingertip. And dioxins don't break down. They're what chemists call persistent organic pollutants. Once they're created, they stick around in the environment for decades, accumulating in living tissue. They concentrate up the food chain, so by the time they reach top predators, including humans, they're present in dangerous levels. But we're just getting started with the plastic nightmare. Modern electronics contain dozens of different types of plastics, each with its own horrifying breakdown chemistry. Flame retardants, chemicals added to prevent fires, become extremely toxic when heated to volcanic temperatures. They break down into compounds that interfere with hormone systems, disrupt brain development, and cause cancer. The really insidious part about these plastic breakdown products is that they're all volatile at volcanic temperatures. That means they don't stay in the lava. They immediately become airborne. So you're not just dealing with localized contamination around the volcano. You're injecting these toxins directly into the atmosphere, where they can travel thousands of miles. Now let's talk about metals, because the chemistry gets even more terrifying. Aluminum, which is in everything from soda cans to car parts, reacts with molten rock like thermite. If you've ever seen thermite demonstrations, you know it burns hot enough to cut through steel and creates violent, uncontrollable reactions. Throw aluminum garbage into a volcano, and you're essentially setting off thermite charges inside a pressurized geological system. The reaction produces aluminum oxide particles that become airborne and can travel vast distances on atmospheric currents. These particles are small enough to penetrate deep into lungs and cause permanent respiratory damage. Car batteries present their own special nightmare scenario. When lead-acid batteries are heated to volcanic temperatures, they release lead vapor, and lead doesn't just disappear when it cools down. It settles on vegetation, contaminates soil, and enters the food chain where it accumulates in bone tissue and interferes with nervous system development. The lead contamination from just a few car batteries disposed of volcanically could make hundreds of square miles of agricultural land unsafe for food production. And lead poisoning is permanent. Once it's in your system, it never comes out. Mercury from electronics creates an even more insidious problem. In volcanic environments, mercury transforms into methylmercury, which is a potent neurotoxin that caused Japan's infamous Minamata disaster when it accumulated in fish. Methylmercury is hundreds of times more toxic than regular mercury, and it bioaccumulates, meaning it gets more concentrated as it moves up the food chain. The volcanic heat creates the perfect conditions for this transformation. Mercury vapor rises in the volcanic plume, reacts with sulfur compounds in the atmosphere, and comes back down as methylmercury in rainfall. This contaminated rain can poison watersheds hundreds of miles from the volcano. But here's where the atmospheric consequences really multiply these dangers into something genuinely catastrophic. Volcanic plumes naturally reach 30,000 feet into the atmosphere. That's cruising altitude for commercial aircraft. Up in the jet stream where atmospheric currents circle the globe, when you add toxic garbage gases to a volcanic plume, you're not just creating local pollution. You're injecting poison directly into the planetary circulatory system. Computer models from MIT show that waste-contaminated volcanic emissions could circle the entire Earth in just 3 weeks, depositing toxins on every continent. Let me paint you a picture of what this global contamination would look like. A major volcanic eruption mixed with garbage disposal could create acid rain with a pH of 2. That's about as acidic as lemon juice, but falling from the sky across entire continents. This isn't the mild acid rain that damaged some monuments in the 1980s. This is industrial-strength acid falling on crops, forests, buildings, and water supplies. Acid rain at pH 2 would dissolve concrete. It would corrode metal infrastructure. It would kill most plant life on contact and make soil unable to support agriculture for decades. We're talking about creating dead zones that could span thousands of square miles, areas where nothing could grow and nothing could live. The atmospheric chemistry gets even more complex when you consider the interaction between garbage breakdown products and natural volcanic gases. Volcanoes naturally emit sulfur dioxide, carbon dioxide, and various other gases. When these natural emissions mix with the complex cocktail of chemicals from garbage breakdown, they create entirely new compounds that we've never seen in nature. Some of these hybrid compounds are more toxic than either the natural volcanic gases or the garbage breakdown products alone. It's like mixing cleaning chemicals under your sink. Sometimes the combination creates something far more dangerous than the individual components. The chlorine compounds from plastic breakdown, for example, react with sulfur dioxide to create sulfur chloride gases. These compounds can persist in the atmosphere for months, slowly breaking down into acids that contaminate precipitation over vast areas. We're not just talking about one toxic event. We're talking about turning the entire atmospheric system into a chemical weapons delivery mechanism, electronic. Waste adds rare earth elements to this toxic mixture, and many of these elements become radioactive when exposed to the extreme conditions inside volcanic systems. So now you're not just dealing with chemical contamination, you're potentially creating radioactive fallout that could spread across continents. The organic compounds in garbage create their own category of atmospheric nightmare. When organic materials burn in oxygen-limited environments, like deep inside volcanic systems, they produce compounds called polycyclic aromatic hydrocarbons, or PAHs. These chemicals are carcinogenic, mutagenic, and extremely persistent in the environment. PAHs from volcanic garbage disposal would enter the global atmospheric circulation and eventually settle everywhere, in Arctic ice, in deep ocean sediments, in agricultural soil, in drinking water supplies. Once PAHs are in the environment, they stay there for decades, slowly accumulating in the tissues of everything that lives. But perhaps the most disturbing aspect of volcanic garbage chemistry is how it affects the volcanic system itself. All of these foreign chemicals don't just pass through the volcanic environment unchanged. They interact with the molten rock. potentially altering the behavior of the volcano itself. Chlorine compounds from plastic breakdown can make magma more explosive by changing its chemical composition. The additional gases created by garbage combustion can increase pressure in volcanic systems, potentially triggering eruptions that wouldn't have happened naturally. We could literally be turning relatively stable volcanoes into volcanic time bombs. The heavy metals from electronic waste can contaminate magma chambers, creating new types of volcanic rocks with unprecedented levels of toxic elements. These contaminated volcanic deposits would remain dangerous for geological timescales. We're talking about contaminating Earth's crust for millions of years, and here's something that really keeps volcanic scientists awake at night. We don't fully understand how all these chemical interactions would play out in complex volcanic systems. The chemistry I've described is based on laboratory studies and computer models, but real volcanic systems are far more complex than anything we can recreate in a lab. We could be creating chemical reactions that have never occurred in Earth's history. We could be triggering cascading chemical processes that contaminate not just the immediate environment, but alter atmospheric chemistry on a global scale for decades. The scariest part is that once you start these chemical processes, there's no way to stop them. You can't recall volcanic emissions once they're in the atmosphere. You can't extract toxic compounds from magma chambers once they've been introduced. You can't undo the chemical contamination of the global environment. One major waste-contaminated volcanic eruption could create dead zones spanning thousands of square miles, contaminate atmospheric systems for decades, and alter the chemistry of our planet in ways we can't predict or control. This is why every attempt at volcanic waste disposal has ended in disaster. It's not that people weren't smart enough to do it safely. It's that the chemistry makes safe volcanic waste disposal fundamentally impossible. The forces and chemical reactions involved are simply too powerful, too complex, and too unpredictable for human control. But here's what gives me hope about this whole nightmare scenario. Understanding why volcanic disposal is so catastrophically dangerous has led scientists to develop waste processing technologies that actually work. Technologies that can handle the complex chemistry of modern waste in controlled environments, capturing and neutralizing toxic compounds instead of spreading them across the globe. These solutions exist. They're being used successfully right now in multiple countries. And the best part? They were developed by scientists who started by asking the same question we've been exploring. What happens when you try to dispose of garbage using extreme heat? The difference is, instead of throwing the garbage into uncontrolled volcanic systems, they figured out how to recreate and control the beneficial aspects of extreme heat processing, while avoiding all the catastrophic chemistry we've been discussing. So after all this talk about catastrophic chemistry and impossible solutions, you might be feeling pretty depressed about our waste problem. But here's the thing that gives me genuine hope. While we've been fantasizing about throwing garbage into volcanoes, some incredibly smart people have been quietly revolutionizing waste management in ways that actually work. Let me tell you about Sweden, because what they've accomplished is nothing short of remarkable. While most countries are struggling to figure out what to do with their garbage, Sweden has such an efficient waste management system that they actually import 800,000 tons of garbage annually from other countries. 800,000 tons. They're literally importing other people's trash because their waste processing systems are too efficient. Here's how they do it. Sweden has built a network of waste-to-energy plants that reach volcano-like temperatures. We're talking about 2,000 degrees Fahrenheit. But unlike volcanoes, these systems capture every single emission. They use sophisticated filtering systems, chemical scrubbers, and pollution controls that ensure nothing toxic escapes into the atmosphere. The result? Only 1% of Swedish waste ends up in landfills. 1%. The rest gets turned into electricity that powers 800,000 homes and heating systems that warm 1 million people. They've essentially turned their garbage into a renewable energy source. But here's what's really brilliant about the Swedish system. It's not just about burning garbage more efficiently. They've redesigned their entire approach to waste, starting with the assumption that nothing should be thrown away, because there is no away on a finite planet. Swedish households sort their waste into multiple categories, but not in the overwhelming way you might imagine. They've made it simple and logical. Food waste goes to biogas plants, where bacteria break it down into methane for heating and electricity. Metals get recycled into new products. Plastics are either recycled or processed through controlled incineration with complete emission capture. Even the ash from their waste-to-energy plants gets recycled into construction materials for roads and buildings. What Sweden proves is that the volcano disposal fantasy was asking the wrong question all along. Instead of how do we make garbage disappear, they asked, how do we make sure nothing becomes garbage in the first place? But even more impressive than Sweden's high-tech approach is what's happening in a small Japanese town called Kamikatsu. With a population of just 1,500 people, Kamikatsu has achieved something that seems impossible. They're on track to produce zero waste by 2030. Zero waste. Think about that for a moment. An entire town where nothing gets thrown away. Here's how they do it, and this is where it gets really interesting. Kamikatsu has no garbage trucks, no incinerators, no landfills. Instead, residents sort their waste into 45 different categories. Now, before you start thinking that sounds impossibly complicated, let me explain how it actually works. The town built a centralized sorting facility where residents bring their waste and sort it themselves. But this isn't some grim chore. They've turned it into a social experience. People meet their neighbors, catch up on local news, and take pride in how efficiently they can sort their materials. Kids learn about the life cycle of different materials by seeing where everything goes. Old kimonos get turned into beautiful bags and clothing. Food waste feeds community composting systems that produce soil for local gardens. Anything that can't be recycled or composted gets creatively repurposed. The town maintains a circular shop where people can take items they need and leave items they don't. Kamikatsu reached 80% waste diversion by 2020, meaning 80% of everything that would normally be thrown away gets turned into something useful instead. And they're not stopping there. They're aiming for 100% by 2030. What's remarkable about Kamikatsu is that they prove waste is fundamentally a design problem, not a disposal problem. When you design systems that assume everything has value and can be used for something, the waste problem largely disappears. But let me tell you about some of the revolutionary technologies that are scaling these approaches to work for large populations. Scientists at Kyoto University discovered something that sounds like science fiction: bacteria that can actually eat petty plastic. The plastic in most beverage bottles. These bacteria break down plastic completely in just 6 weeks, turning it back into the basic chemicals it started from. No toxic byproducts, no persistent pollutants, just natural decomposition of synthetic materials. The implications are staggering. We could potentially use these bacteria to clean up existing plastic pollution while preventing new plastic from accumulating in the environment. British company Recycling Technologies has created machines that can turn any plastic waste back into oil through a process called pyrolysis. The machines heat plastic waste in an oxygen-free environment, breaking it down into synthetic crude oil that can be refined into new plastics or used as fuel. It's like running the petroleum industry in reverse, turning plastic waste back into the oil it came from. This creates what's called a true circular economy for plastics. Instead of using petroleum to make plastic that gets used once and thrown away, we could use these machines to turn plastic waste back into oil indefinitely. Every plastic bottle could potentially become a new plastic bottle over and over again, forever. Norway has taken high-temperature waste processing to an entirely new level with plasma gasification plants. These facilities heat waste to 10,000 degrees Fahrenheit. That's 5 times hotter than volcanic lava. but they do it in completely controlled environments with total emission capture. At 10,000 degrees, any organic material breaks down into its basic atomic components. The process produces clean synthetic gas that can be used for fuel, and the only solid byproduct is an inert glass-like material that's actually useful for construction. It's like having a tame, controlled volcano that processes waste without any of the catastrophic atmospheric chemistry we talked about earlier. What's brilliant about plasma gasification is that it can handle mixed waste streams. You don't need to sort everything perfectly, because the extreme temperatures break down all organic materials completely while safely capturing and neutralizing any toxic compounds. These technologies work because they control the process completely, unlike the chaos of throwing trash into uncontrolled volcanic systems. They operate at controlled temperatures in controlled atmospheres, with sophisticated emission controls and byproduct capture. They turn the destructive chemistry of extreme heat into constructive chemistry that produces useful outputs. But the most exciting developments might be the ones that prevent waste from being created in the first place. Companies are developing packaging materials made from algae, mushroom fibers, and other biological materials that decompose completely in weeks rather than centuries. Clothing companies are creating fabrics that can be composted at the end of their useful life. Electronics manufacturers are designing products for complete disassembly and material recovery. The European Union has implemented extended producer responsibility laws that make manufacturers responsible for the entire life cycle of their products, including disposal costs. This creates powerful economic incentives to design products that last longer, can be repaired easily, and can be completely recycled at the end of their useful life. The result is a fundamental shift in how products are designed. Instead of planned obsolescence and disposal problems, manufacturers are competing to create products that generate the least waste and have the highest material recovery rates. 3D printing technologies are enabling distributed manufacturing that eliminates much packaging and transportation waste. Instead of shipping finished products around the world, companies can ship digital designs and print products locally using recycled materials. Biotechnology companies are developing bacteria and enzymes that can break down specific waste streams. There are now biological processes that can recover rare earth elements from electronic waste, break down complex chemical pollutants, and turn organic waste into valuable chemicals and materials. What all of these solutions have in common is that they work with natural systems instead of fighting against them. They use controlled processes instead of hoping uncontrolled natural forces will solve human problems. Most importantly, they recognize that Earth is a closed system where nothing truly disappears. Everything just transforms into something else. The volcano disposal fantasy was appealing because it promised to make our problems disappear without changing how we live. But the real solutions require us to think differently about the relationship between human activities and natural systems. They require us to design industrial processes that work like natural ecosystems, where the waste from one process becomes the input for another. These solutions exist right now. They're being implemented successfully in multiple countries. They're creating jobs, reducing environmental impact, and proving that the waste crisis is entirely solvable using technologies and approaches we already understand. The only question is whether we'll choose to implement them at the scale needed to address the global waste crisis. Because unlike throwing garbage into volcanoes, these solutions actually work. And they work better than the magical disposal fantasies we've been chasing for 2,000 years. So here we are at the end of our journey into one of humanity's most persistent, impossible dreams. We've explored the incredible complexity of volcanic systems, the horrifying scale of our waste crisis, the catastrophic chemistry that happens when the two meet, and the real solutions that actually work. But I want to leave you with something deeper an understanding of why the volcano disposal fantasy has captivated us for 2,000 years, and what that reveals about how we think about our relationship with the planet. The volcano disposal dream reveals something fundamental about human psychology that goes way beyond waste management. We're drawn to permanent solutions, to making problems literally disappear. There's something deeply appealing about the idea of finding a perfect away place where our mistakes and excess just vanish forever. Think about how this pattern shows up throughout human history. Ancient cultures threw sacrifices into volcanoes, believing it would please the gods and solve their problems. Modern humans want to throw garbage into volcanoes, believing it will please the environment and solve our waste crisis. Both represent the same kind of magical thinking, the hope that natural forces will solve problems we created without requiring us to change how we live. This isn't just about volcanoes. We've been chasing away places for our entire existence as a species. For most of human history, away was just over the hill or downstream or on the other side of the forest. The ocean seemed infinite, so we dumped everything there. The atmosphere seemed infinite, so we pumped our emissions into the sky. Space seemed infinite, so we started fantasizing about shooting our garbage into the sun. Each time, we eventually discover that there is no away on a finite planet. Ocean dumping seemed perfect until we discovered garbage gyres and acidification. Atmospheric dumping seemed harmless until we understood climate change and ozone depletion. Shooting waste into space sounds brilliant until you calculate that it costs $10 million to launch a single ton into orbit. We keep seeking consequence-free consumption because facing the real solution, producing less waste and designing better systems, requires changing how we live. The volcano represents our eternal search for a technological fix that will allow us to continue destructive patterns without consequences. But here's what's fascinating about human nature. Understanding why bad ideas attract us often leads to breakthrough insights. The volcano disposal dream taught us about atmospheric chemistry, which led to better pollution controls. Failed experiments with high-temperature destruction inspired plasma gasification technology. Most importantly, realizing there's no away on a finite planet sparked the zero-waste movement that's now transforming cities worldwide. Sometimes the worst ideas, when examined closely, reveal the best paths forward. The volcano fantasy forced us to confront the chemistry of our waste, the complexity of natural systems, and the limitations of magical thinking. It taught us that real solutions require understanding and working with natural processes. Rather than hoping to overpower them, the psychology behind the volcano disposal dream also reveals something important about how we process overwhelming problems. When you're faced with 5.9 million tons of daily garbage production, 2 billion tons annually, plastic gyres the size of continents, and electronic waste growing exponentially, the human mind naturally looks for simple, dramatic solutions. It's the same psychology that makes people believe in conspiracy theories or miracle cures. When problems seem too complex to understand and solve through normal means, we become attracted to explanations and solutions that promise to cut through all the complexity with one dramatic intervention. The volcano solution appeals to us because it's simple, permanent, and dramatic. Throw the garbage in, problem solved. No need to change anything about how we live or what we consume. It's the ultimate expression of what psychologists call solution aversion, when we reject real solutions because they require effort or change, and instead chase impossible solutions that promise effortless results. But the volcano fantasy also reveals something hopeful about human nature. Even our worst ideas often contain the seeds of better ones. The dream of using extreme heat to destroy waste led to controlled high-temperature processing that actually works. The desire to make waste disappear permanently led to circular economy designs that eliminate waste by turning everything into inputs for something else. Our attraction to the volcano solution forced us to deeply understand the chemistry of waste disposal. And that understanding enabled the development of technologies that safely achieve what we were hoping volcanoes could do unsafely. This pattern, pursuing impossible solutions that teach us how to develop possible ones, shows up throughout human technological development. Our fantasies about flying led to the study of aerodynamics and eventually to actual flight. Our dreams of turning lead into gold led to chemistry and eventually to nuclear physics. Our hopes of finding the fountain of youth led to medicine and life extension technologies. The volcano disposal dream fits perfectly into this pattern. It was never going to work as originally imagined, but pursuing it taught us essential lessons about waste chemistry, atmospheric science, and systems thinking that enabled real solutions. Understanding this pattern also helps us recognize when we're falling into similar traps with current environmental challenges. The idea of geoengineering our way out of climate change by manipulating atmospheric chemistry has the same appeal as volcano disposal, a dramatic technological fix that would allow us to avoid changing how we live. And like volcano disposal, geoengineering schemes tend to have catastrophic unintended consequences when examined closely. The real lesson isn't about volcanoes or garbage or even the chemistry that happens when they meet. The real lesson is that Earth is a closed system where everything we do comes back to us. Whether through toxic volcanic plumes, plastic-filled oceans, or climate-changing atmospheric emissions, there's no magical disposal site. There's no away place where problems disappear without consequences. There's only the world we share, and the choice to care for it or poison it, but that limitation is also an opportunity. When you accept that Earth is a closed system, you start designing human activities to work like natural ecosystems, where the waste from one process becomes the input for another. You start thinking about durability instead of disposability, about circular flows instead of linear consumption, about regeneration instead of depletion. The countries and communities that have solved their waste problems haven't done it by finding better disposal sites. They've done it by eliminating the concept of waste entirely, by designing systems where everything has value and nothing gets thrown away. This shift in thinking, from disposal to circulation, from waste to resources, from linear to circular, represents a fundamental evolution in how humans relate to the natural world. Instead of seeing nature as a disposal site for human excess, we're learning to see human activities as part of natural cycles that can either support or disrupt planetary systems. The volcano disposal fantasy represented the old way of thinking. Find a place to hide problems without changing anything fundamental about how we create them. The new way of thinking asks different questions. How do we design products that don't become waste? How do we create industrial processes that regenerate rather than degrade natural systems? How do we live in ways that enhance rather than diminish the planetary systems that support all life? These aren't just technical questions. They're philosophical and spiritual questions about our relationship with the world we inhabit. They require us to move beyond magical thinking toward ecological thinking, beyond domination toward partnership, beyond extraction toward regeneration. The journey from volcano disposal fantasy to circular economy reality represents one of the most important transitions in human history. The shift from seeing ourselves as separate from nature to understanding ourselves as part of natural systems that we can either support or destroy through our choices. That transition is happening right now. In cities and companies and communities around the world, people are choosing regeneration over destruction, circularity over waste, partnership over domination. They're proving that the future doesn't require throwing our problems into fire mountains. It requires designing systems where problems become solutions, where waste becomes resources, where human activities enhance rather than degrade the living world. The volcano disposal dream taught us that there's no magic bullet for the environmental challenges we've created. But it also taught us something more important, that understanding complex natural systems and working with them intelligently can achieve results that seem magical. Even though they're based on solid science and careful design, the real magic isn't in finding perfect disposal sites. The real magic is in discovering that we can create ways of living that generate abundance rather than waste, that enhance natural systems rather than destroying them, that leave the world more beautiful and healthy than we found it. That's the future the volcano disposal fantasy was really pointing toward all along. Not a way to hide from the consequences of our choices, but a way to make choices that create the world we actually want to live in.